Hello everyone, in this video we will learn about a new integration technique called integration by parts. By the end of this video you will first be able to explain how to derive the integration by parts formula, and second, recall a simple formula for integration by parts. To illustrate the importance of integration by parts, consider the following integrals. First, we have the integral of e to the x dx, and second, we have a slightly modified integral of x times e to the x dx. Now this first integral is a pretty elementary integral. We already know how to evaluate it from Calculus 1. This is probably the easiest integral to remember, and it is simply equal to e to the x plus x. However, the second integral is only slightly different, with this x appearing in the integrand. But at the moment, this makes this impossible for us to integrate. In order to integrate this, we are going to need to use integration by parts. Now in the future, for the sake of time, I am going to abbreviate this to IBP. To derive the integration by parts formula, we are going to recall that the substitution rule for integrals from Calculus 1 arises when we reverse the chain rule for derivatives. Well, integration by parts is obtained with a similar strategy, but now we're going to reverse the product rule for derivatives. So, as we are deriving our formula, we are first going to start with the derivative of a product. So we are going to compute the derivative with respect to x of f of x times g of x. Now this is a nice review from Calculus 1 of a basic derivative rule. This is going to be the first function f of x times the derivative of the second, so that's g prime of x, plus the second, which is f prime of x, times the first, which is g of x. Well, now we want to talk about integrating functions, not differentiating them, so we are going to integrate both sides of this function. Integrate both sides of this equation. So we will integrate our derivative on the left, and we're going to do that with respect to x. We are going to integrate both of the terms on the right, so we can split that up. Well, this implies then on the left we have the integral of a derivative, so those will cancel each other out since they are inverses. We have f of x times g of x, and this is equal to the integral of f of x g prime of x dx plus the integral of f prime of x g of x dx. The last step that we are going to do, the third step in deriving this formula, is to simply rearrange. So we are going to subtract this term, the integral of f prime of x g of x dx, from both sides, and then I'm going to rearrange the order so that I have the integral of f of x g prime of x dx on the left, and this is equal to f of x g of x minus the integral of f prime of x g of x dx. Now this formula right here is the integration by parts formula, but you might look at that and think, well, that's not an easy formula to remember. Thankfully, we have a way of rewriting this formula to make it a bit easier to remember. So, to obtain our easy formula, we are going to start by letting u equal f of x and dv equal g prime of x dx. Well, that allows us to rewrite the left-hand side of our integration by parts formula, since f of x is just u and the rest of this is dv. But we need to figure out ways to get the other pieces on the right-hand side. We are going to get something in terms of f prime of x by differentiating this. So we would differentiate both sides to get du is equal to f prime of x dx. So that takes care of the f prime of x dx, but we also need a way of writing g of x. Well, we have a g prime of x, so if we integrate that, integrating both sides with respect to the appropriate variables, so we integrate the left side with respect to v, and we get just simply a v. we integrate the right-hand side with respect to x, and we cancel out our derivative to get a g of x. So now we have that g of x is equal to v, and f prime of x is equal to du. So this gives us then our easier formula. The integral of u dv is equal to f of x times g of x, so that's going to be u times v, minus the integral of g of x, which is v, f prime of x dx, which is du, so the integral of v du. And we now have our easier to remember integration by parts formula. The integral of u dv is equal to uv minus the integral of v du. Now you know how the integration by parts formula is derived and an easier way to remember the formula, and you're ready to see how to apply it to different integrals in future videos.